This is part C of a four-part project where I take a look at the code in my Python script that is used to monitor the LEDs that the pinball machine is lighting up and converting that into images or videos to display on our video monitor. So take a look, enjoy. I import some of the stuff I need to work with, including the OMX player. I don't need to import FEH since I'm going to run it as a subcommand. It's like a shell command, so I just talk to it and it goes through the directory structure and finds it. The next thing I have is a bunch of descriptions of what the LEDs. I'm going to be inputting a serial string from that test device, and there are 64 bits defined in that serial string, and this simply defines what each of those bits are used for. Now the only numbers I use are these right here, the 1K to 20K bonuses, and the 5, 3, and 2x they're actually multipliers, they're not bonuses, and then somewhere there's a game over. So I use those. I could use any of those. All of those lights are available to me to sample, but right now the code doesn't look at any of those. I set up a few variables. I'm a horrible programmer, and I use global variables that I read and write into to pass information between threads. I forgot the word there for a second. So this little routine has two like background threads that run, one that inputs serial data and one that outputs the images to the screen, and then there's just a little routine in the middle that sits there and checks to see if the lights have changed and updates what should be displayed. So let me take you up to the top. The first thing I do is define those two threads. So the read LEDs is the thing that reads the serial string to determine which LEDs are set. And as you can see right here, it goes and looks for that device, and if it's not there, it just exits the program. So when this program starts up, that thing has to be there and running, which isn't a problem. It starts a lot quicker than the Raspberry Pi, so it will be up and running and sending strings of data in. When it inputs the information, it checks the serial to see if there's anything waiting. The serial data comes in pretty quick, 10 times a second. So it reads a line, and then it flushes the rest. And then it changes that line, that string of information, into a list, an indexable list of locations. It checks the first character to see if it's an S and the last character to see if it's a Z. And those are just some codes I stuck on the string to help identify it. It's the protocol, if you will. And if you got the S and Z, then you'll zero out a checksum, and you'll take all of the characters between that. You go 1 through 16, and you just add those up to make a checksum, and then you compare the checksum you calculated with characters 17 and 18, and if those match, you call it a good string. If it's not a good string, you just throw it away. You don't do anything with it, and you just read another string. Since it's happening over and over and over again, if you miss a string, it doesn't make any difference. So there's no correction, nothing fancy. You just keep reading until you get a good string, and then you use that good string. Okay, and so that's one of the background threads, and this runs over and over and over again. If it finds a good string, it breaks it apart into individual bits and stores those bits in the LED matrix. So let me look at the display thread next. This is the other background thread, and this is just going to display what needs to be displayed. So the first thing it does is, this is, by the way, both of those threads run in a while true loop, so it runs over and over and over again. It never stops. So it checks to see if the global variable change has been set to true, and if it has, it sets it to false. And all that says is the foreground task said, I've made a change, and this thing says, oh, I see you've made a change. I'm going to set it back to false because I'm processing that change. Then the first thing it does is it doesn't know if there is an image playing or a media playing, but it tries to terminate both of them. So it does an image terminate and it does a media quit. And whichever one of those is up and running, it will stop that particular image or video from playing. The base is defined up above. Let me go up there and show that to you. And that's that Sexy Girl Media. Base is Home Pi Sexy Girl Media. So that's where I put all of the Sexy Girl Media. The variable dir is defined by my foreground task that says which directory do I want to show an image from. That's the PGP or the PGV or whatever. So that it picks that directory. It picks a random file from that directory. It joins it with the path to get a fully developed file name, and it just validates that it got a good file. There shouldn't be any way it should get a bad file. All the files in there are good files, but I just figured I would add this as a check because it doesn't hurt. So I just validate that I can read that file from the file path I've developed. And then if I'm in video mode, I send that path to OMXplayer and I set that equal to media. And I mute the media. Some of the media does have audio on it, and that audio will play through the little display on the screen, but you can barely hear it, and it doesn't all have it, and I don't think it adds to the game. So I've muted the audio for now. I sleep for just a tiny little bit, half a second, and then I get the length of this video. If the video gets to the end, it will crap out, basically. It'll stop and it'll trash the program. So I either have to terminate it before it gets there, or I have to do some other error checking, cleanup and stuff. What I do instead, while change is false. So remember, our change is set by the foreground tasks if it needs to change something. So as long as nothing has changed, it watches the media position, and if it's within a half a second of the end of the image, it sets the image back to the beginning. So this is a loop command. The player itself does not have a loop widget, whatever it would be called. So this is a way for me to implement a loop. So the video will endlessly loop until there's a change. And then if there is a change, it issues the media quit. Technically you should never really get up to this media quit, but just in case and it's playing and you got out of here somehow, then it'll quit it. So if it isn't a video, then it's an image. So if it's an image, you create a sub process with the popen, and you send it the command FEH, so that fires off the imagery processor. Hide the pointer. Let me see if I can remember what all these. I don't remember what all these are. This one says the background is black. It's full screen -F, and that's the path for the image you want to display. And once you send that, it'll kick off another process, the FEH process, and it will put the image up on the screen. And so that's that thread. So now you've seen the two threads. Now let's go look at the actual display process. So the first thing it does is it looks to see if the game over light is on. And if it is, checks to see if attract mode is already playing. And if it isn't, if attract mode isn't playing yet, then this is the first time you're dropping into the game over after it's been playing or something. So you set attract playing to true. You set the bonus total to 0, the directory to attract, the video mode to V, and the change to true. And that's it. And then the background task will see that change became true. It'll grab the attract directory, grab that image out of the attract directory, and start playing it. Now we could have multiple different attracts, and then every time it would come in here, it would randomly pick one of those attracts. But right now there's only one, so it'll only play that one. So if the game over light is out, then this will be false, and it will drop down to this else statement. And the first thing it'll do is set attract playing to false, because obviously it's not going to be playing anymore. It takes the current bonus total and it makes it the old bonus total. So this is going to compare the old bonus to the newly calculated bonus to see if any change has occurred. So this little bit of routine gives you point values for whichever bonus lights are on. So the first thing it does is it scans through the first 12 bonuses, and it adds the index value. So if the 1 is on, it adds 1. If the 2 is on, it adds 2. If the 3 is on, it adds 3. So on and so forth, all the way up to the 11th one. I guess it's 1 through 11. And then it looks to see if the 20K is on. Now 20K sets you into video mode. So if 20K is on, it sets you into video mode. Otherwise, it sets the mode to picture mode. And then it looks at the bonus LEDs, because if any of the bonuses change, you want to also change to a new image. So if the 2X's come on, it adds 25. If the 3X's come on, it adds 50. And if the 5X comes on, it adds 100. And then it just does this little thing where if the bonus is over 9, it puts you into the R rating. If the bonus is less than 9, you're in the PG rating, and you're in portrait mode only. That's why I said you can't have any PG videos, because once you get over 9, you go into R automatically. Okay, so that's kind of done the initial setup, and then it looks at the bonus total and checks to see if it's greater than the old bonus total. And if it is, there's been a change. So it takes the directory and video mode that's been calculated up here and puts that into the directory variable, and it sets change mode to true. That's the whole thing. And this thing runs non-stop. It doesn't have any real error stuff. I just wanted to show you how it all gets kicked off right down here at the end. I set the threading thread to read LEDs and the second thread to display things, and I start both of them, and then I do an endless loop of while true, do a display, and I tried to put an exit if that thing goes away. That doesn't actually work because it leaves the stuff still hanging. So I'm playing around with that. I'm trying to see if I can get it so I can unplug the tester or the actual data stream and have the image stop and go away and get into the Pi so I can work on it. Right now, in order to work on the Pi, I have to unplug that serial stream and then reboot the Pi, and when the Pi reboots, up here at the top of this program or this script, it says if it's not there, just exit. So this script will exit if the serial stream input is not there, and then you can go in and you can manipulate it and stuff. But if it is there at the start, you go into an endless loop and you stay in an endless loop until you power the thing off. So that was a pretty detailed look at the Python script that I used to produce the imagery controller to use in our pinball machine. There's not really a lot of code there. It's a pretty small script, thanks to a lot of other people doing the work of producing the display and the Python glue needed to put the OMXplayer together with Python and let you control the videos. So with those things, I think I have a pretty good solution here in hand. It's pretty responsive. So in the last part of this video, which is coming up, part D, we'll do a little testing to make sure that this new build is working correctly and displaying the images it's supposed to, and do a little bit of the final configuration work necessary to get it to come up. So thanks a lot for watching. I hope you're enjoying this little series.